Hello, I invite you to a short video, the second part of the introduction to the influence line. Today, as promised, we will make a cantilever beam. This is a very easy beam, but as I say, it will later be useful for long Gerber beams. For sectional forces, it will be very useful, what we will derive today. In the first part, I made a beam with two supports, in the third part with a vertical roller and sliding support. So here we have the vertical reaction VA and the moment in the fixture. Of course, there is also a horizontal reaction that is 0. And now let's consider from the sum of projections on the y-axis. We see that the reaction VA, depending on where the force is, it can be at any point. And so the whole vertical force is carried by the reaction VA. So we can immediately draw reaction VA equal to 1, and the moment from the sum of moments at point A, let's say, well, let's consider two situations. When the force is at the very beginning, from the sum of moments at point A, the influence line of reaction, MA, is equal to 0. And when the force is at the very end, we have such an equation 1 at arm L plus MA equals 0. So MA must equal minus L. So from 0 to minus L, as I said in the previous video, the influence line will always be a linear function. We can connect them. These are already the influence lines of these support reactions. But let's do it quickly, analytically as well. What I said, Massachusetts, here we will have plus 1 times x equals 0. Aha, here it was supposed to equal 0. So MA is minus x, for coordinate 0 is 0, for coordinate L is minus L. From the sum of projections on the y-axis, Virginia minus 1 is equal to 0, so VA is equal to 1, and this is how these influence lines look. This is simple. Now let's also do easy sectional forces. First, the influence line of the shear force in cross-section K, here as in the previous part. In two cases, the force is before the cross-section and after the cross-section. It will always be like this with these large Gerber beams, always in two cases. If the force is before the cross-section and when the force is after the cross-section, that is from 0 to A. Well, we look from the right side, well, an easy thing. If the force is from 0 to A, then we do not see anything looking from the right side, meaning the shear force is equal to 0. So the second case, when the force is after the cross-section, now freely, looking from the right or left side, here I look from the right side, remember that the positive direction of the shear force down is downward, when looking from the right side, and this one is directed downward. So it is positive. If I were looking from the left side, it would be the same. Looking from the left side, the positive shear force is directed upward, meaning it is in the cross-section on the left side, which would also be a positive one. And that's all, we can draw it. When the force is before the cross-section, we have 0. And when the force is after the cross-section, we have 1. And now the influence line of the moment in cross-section K. So again, when the force is before the section, I look from the right side and have 0, and when the force is past the section and I look here from the left side, then we will have when the force is... No, here I'm looking from the right side. I don't know why I wrote it was from the left. Now, looking from the left side, I would have ma plus VA times x, but here I see that it is taken from the right side, so that's a clockwise unit, meaning negative. Because looking from the right side, you remember, you are after a strength course. You remember that the positive direction in this section, the moment direction, is such, meaning counterclockwise. So this unit being past the section, looking here from the right side, creates a clockwise moment for me, meaning negative. And on such an arm, let's say the force is here, so the arm will be like this, and it will be the whole length x, subtract this, x minus a. This is from the right side. Now I check the start and end of the interval. When I insert a, the parentheses become 0, I have 0. When I insert L, meaning a plus b, then I am left with minus b. So when the force is before the section, we have 0, and when it is past the section, we have a constant value. Sorry, we don't have a constant value. But because this is a linear function, from 0 to minus b at the end of the interval. And that's it. These are easy things, but as I say, they will come in handy later. I hope there won't be questions here, but if anything, I encourage you to ask questions under the video. Feel free to like us, visit us, and of course subscribe. Take care, bye!